Hello, this is lesson 1-2. This is on page 7, and we covered this on August 30th, 2017. 16. Now, at the beginning of every lesson, we have learning targets. So the first learning target is to create equations in two variables to represent relationships between quantities and to graph two variable equations. So in lesson 1-1, we actually went ahead and solved equations with one variable. So that's an example of this right here. So we basically just subtract x on both sides and we get x equals 0. So before we begin learning about two variable equations, it's very important to know about the function cycle. So the function cycle, you begin with the function. In this case we have f of x equals 2x, and from the function we want to go ahead and put it into a table. Now before we fill in the table, let's go ahead and label the x. Another way of calling the x value is the input, and the y we can call it as the output. Another name for the x value is the independent variable. And the y is going to be the dependent variable. So x is the input or independent variable, y is the output or dependent variable. Y can also be called, you may see a table where instead of having y, you also have f of x. So how do we go ahead and fill this table? Well, since x is the independent variable, we can basically choose any value of x. But once we choose a value of x, which is our input, we have to take each input and plug it into the equation. So if we plug in 0 in for x, we have to multiply it by 2, 0 times 2. That is going to give you your output, which is 0. Again, take your input of 1, plug it in for x. 2 times 1 is 2, which is your output. And then finally, taking 2, plug it in for x. 2 times 2 is 4. Okay, so we went from function into a table. Now we can go from our table into an ordered pair. So basically an ordered pair is just writing the x and the corresponding x and y values. So here we have an ordered pair of 0, 0. We also have the ordered pair 1, 2, and the ordered pair 2, 4. So we can basically take this information from the table and put it into an ordered pair, and this also represents a function. Now once you have your ordered pair, you can go ahead and take them. Each ordered pair has the x and y coordinates. We can take these ordered pairs and graph them on an x and y plane. So here's the x-axis. This is also the y-axis. So let's go ahead and plot these ordered pairs. Here is 1, 2, and here is 2, 4. So the ordered pairs on a graph are represented by a point. Let's go ahead and draw a straight line through those points. Alright, excellent. So we started with the function f of x equals 2x. We converted the function into a table, and from a table we created an ordered pair representation, and from the ordered pair we created a graph. Now what if you have the graph and you want to go ahead and find what the equation is. Well, from the graph, you're gonna have to have 2 points. So these are our 2 points, 1, 2, and 2, 4, and use a formula for slope, and this is called the slope formula. Now, another way that we call slope is rise over run. So when we take our x2, y2, and x1, y1 values and plug it into the slope formula, we basically get 4 minus 2 divided by 2 minus 1, which comes out as 2 over 1. So 2 is basically our rise, and 1 is our run. Now, when we go ahead and go from one point to the other, notice that we rise 2 and we run 1 in order to get to the next point. So this is the significance of rise over run. So notice that the slope formula only gives us our slope. We need to use this formula here, which is the point slope formula, in order to find the equation that leads us to the function. So you plug in 2 in for m, and you basically can pick any one of these. In this case, I picked x1, y1 in order to plug in for, so to plug it into the point slope formula. So y1 is 2 and then x1 is 1. So here we just go back to the fundamentals. You have to distribute the 2, which gives you 2x minus 2. And then to solve for y, you add 2 to both sides. And what you get in the end is the equation that we started with, which is y equals 2x, which can also be written as f of x equals 2x. So that takes us back to the function that we started with, and that completes the function cycle. Now, when we have it as y equals 2x, it's in the form of y equals mx plus b, where m again is the slope and b is the y-intercept. So you can see that the slope is again rise over run, where we rise 2 and run over 1. And the y-intercept, when you take a look at the graph, the y-intercept basically tells you where it intersects the y-axis. So in this case, our y-intercept is plus 0, and you can see that it intersects the y-axis at y equals 0. One final thing about this function is that it is in the shape of a line. Now, because it is in the shape of a line, this function is the function above is a linear equation, because it has a constant rate of change. So all linear functions have a constant rate of change. So that completes our function cycle. The function cycle is going to be something that we're definitely going to look throughout this lesson, and also throughout this semester. So these are important notes to have. Now let's go ahead and begin with the first paragraph of lesson 1-2. And again, always ask yourself what is going on. Understand the detail of the text. So, at Sapphire Island, visitors can rent inner tubes to use in several of the park's rides and pools. Maria works at the rental booth and is preparing materials so that visitors and employees will understand the pricing of the tubes. Renting a tube costs a flat fee of $5 plus an additional $2 per hour. As you work in your groups on items 1 through 7, review the above problem scenario carefully and explore together the information provided and how to use it to create potential solutions, discuss your understanding of the problems, and ask peers or your teacher to clarify any areas that are not clear. Question number 1. Maria started making a table that relates the number of hours a tube is rented to the cost of renting the tube. Use the information above to help you complete the table. So the guiding question here is, if you rented a tube for 1 hour, how much will it cost? Well, if we take a look at the paragraph above, it says that we have a flat fee of $5 plus $2 per hour. So if I rented for 1 hour, it's going to cost me $5 plus the $2 for that hour, which gives me $7. Now, an important thing about a flat fee is that you only get charged that fee one time, regardless of how many hours you actually use the tube. So if I have 2 hours that I wanted to rent the tube, I'm still going to get charged just $5, but since I'm using it for 2 hours, for each hour I get charged $2, which basically comes out to $4, and when I add 5 plus 4, that's going to give me a total cost of $9. So I can go ahead and plug these in, and when you start calculating the cost for 3 hours, you can begin to see a pattern here, and the pattern is that the cost increases $2 for every hour. So that basically explains question number 2. Explain how a customer could use the pattern in the table to determine the cost of renting a tube for 6 hours. So if we wanted to rent the tube for 6 hours, we basically add 2 to 15, which is 17. So looking at the pattern is that the cost increases $2 an hour, and since at 5 hours we have $15, that means at 6 hours the cost must be $17. Continuing on, next Maria wants to write an equation in 2 variables, x and y, that employees can use to calculate the cost of renting a tube or any number of hours. Question number 3. What does the independent variable x represent in this situation? So going back to your function cycle notes, remember that the independent variable was represented by the first column, which is our x variable, and the dependent variable is represented by the second column, which is the y variable. So keeping that in mind, the independent variable is going to be the hours rented. Now, an explanation is that the number of hours doesn't depend on the cost. It's basically however much time you want to rent a tube is basically your own personal decision. So it's an independent decision. Now, number 4, what does the dependent variable y represent in this situation? Well, that is represented by the second column, which is the cost. Now, why is it called the dependent variable? Well, the cost depends on how many hours you rent a tube, hence that is why it is dependent on, well, that's why it's called a dependent variable. Okay, number 5, write an equation that models this situation. Well, we can look back at our function cycle where we have the table, and from the table we can get the ordered pairs. We can choose these ordered pairs for our x1, y1 values, find the slope using the slope formula, once we find the slope, we can go ahead and use the point slope formula to finally get us to the equation. Now, you can use your intuitive thinking in order to find what the equation is, which many of you were able to find the equation just looking at the patterns. But I'm actually going to go through this in detail using the function cycle, because this is actually very important for your homework once you start doing questions number 18 through 22. You are definitely going to have to use the part of the function cycle to get your equation. So let's go ahead and create the table that we had. We had our x and we had our y. For 1 hour it cost 7, 2, 9, 3, 11. So from this table, let's go ahead and grab 2 ordered pairs. So let's go ahead and pick 1, 7, that's one ordered pair, and 2, 9 as our second ordered pair. Now, once we have both of these ordered pairs, let's label the first ordered pair x1, y1, and the second ordered pair is x2, y2. Now that we have both of these labeled, we can now use the slope formula from your function cycle. The slope formula is y2 minus y1 over x2 minus x1. So basically, y2 is 9 minus y1, which is 7, and we're going to divide it by 2 minus 1. So let's go ahead and simplify this. 9 minus 7 is 2. 2 minus 1 is 1. And so our slope, or m, is equal to 2. Okay, once we have our slope, we have to use the point slope formula, which again is y minus y1 equals m x minus x1. So we found what the slope is, which is 2. Now we know what x1 is, which in this case is 1, and we also know what y1 is, which is 7. So now we have to go ahead and use some basic algebra rules to simplify this, solve for y, and we get our equation. So let's go ahead and first distribute this 2. So if we distribute this 2, we get 2x minus 2, and we have y minus 7. Now we want to go ahead and solve for y, so we need to move 7 to the other side, which we do by adding 7 to both sides. So now we have y, that simplifies to 0, y equals 2x. 7 minus 2 is going to be plus 5. And so here is the equation for number 5. Y equals 2x plus 5. That is the equation. So that is what you will need to do. You need to go through the function cycle. So from a table into an ordered pair, use the slope formula to find the slope. Once you find the slope, use a point slope formula, and then go through the process of the algebra techniques in order to find your equation. So you will definitely need this for the homework for questions number 18 through 22. Okay. How can you tell whether the equation you wrote in item 7 correctly models the situation? Well, let's take a look at our table. And the equation that we came up with was y equals 2x plus 5. Now remember that the first column, the x variable, was basically our input, and the y was the output. And what you can do is basically take each input, plug it into the equation for x. So if we plug in 1 in for x, we basically have 1 times 2, which is 2, plus 5, which gives us 7, which is our output. And so that is indeed correct. We can go one by one for each of these inputs and make sure that we get the correct output. So that's how you can check to see if the equation is correct. Number 7, explain how an employee could use the equation to determine how much to charge a customer. Okay, so the guiding question for this one is basically how much would the cost be if I wanted to rent a tube for 2 days. And the way this is basically you as the entrepreneur explaining to an employee of yours how much they would charge. So I'll leave this up to you to come up with your own explanation. Continuing on, Maria also thinks that it will be useful to make a graph of the equation that relates the time in hours a tube is rented and the cost in dollars of renting a tube. List 5 ordered pairs that lie on the graph of the relationship between x and y. Again, the ordered pairs come directly from the table, so the ordered pairs that we had is 1, 7, 2, 9, 3, 11, 4, 13, and 5, 15. Number 9, use the grid below to complete parts A and B. Write an appropriate title for the graph based on the real world situation. You also write appropriate titles for the x and y axis. Okay, so this is basically you as the entrepreneur coming up with a title for this. So tube rental. Okay, now remember this is the x-axis, which is represented by the independent variable. Remember in our table we said that the input is also the independent variable, and notice that what we have here is the hours rented. So the title for the x-axis should be the hours rented. Now for the y-axis, we can look back at our table and notice that it is the cost. So our y-axis we're going to label as cost in dollars. Okay. Now we can take the ordered pairs that we had. So 1, 7 is here, and then we also had the ordered pair 2, 9, 3, 11, and we can go ahead and create that graph. So there's the graph right there. Alright. So graph the ordered pair, connect the points. Okay, so it looks like we have a straight line. Based on the graph, explain how you know whether the equation that models the situation is or is not linear. So we have a straight line, so I'm going to say that it is linear. Why is it linear? Well, take a look at your notes. When we went over the function cycle, f of x equals 2x, we determined that the function is linear, and the reason is because it has a constant rate of change. So this is why this function is linear, because it also has a constant rate of change. Notice that our slope is the same. We're rising 2 and going over 1, rising 2, going over 1. So that's what we mean by constant rate of change. Explain why the graph is only the first quadrant. So another way of asking that is, why are the x and y values only positive? So notice that the hours start from 0, and then we just go to basically to positive hours. So here's basically the first quadrant. Remember from geometry, here is the second quadrant, third quadrant, and fourth quadrant. So if you are in the second quadrant, you have negative hours, which I'll leave to you to conclude if that makes sense or not. And if you are either the third or fourth quadrant, you notice that your cost begins to have negative values, which I'll leave up to you to determine if that makes any sense or not. Alright, question number 12. What is the y-intercept of the graph? Describe what the y-intercept represents in this situation. Okay, so looking back at the ordered pairs, if we go ahead and look at our equation that we came up with, which is y equals 2x plus 5, remember from our function cycle, this function is in the form of y equals mx plus b, where m is the slope and plus b is the y-intercept. So we can determine what the y-intercept is going to be, which in this case is going to be 5. Now, what is the ordered pair for the y-intercept? Well, we know that we have 5 here, and if we look at the graph, we can see that the ordered pair is 0, 5. So describe what the y-intercept represents. Well, basically tell me what is, remember the x, this is an xy coordinate. So what does 5 mean? And remember, look at your graph and tell me, what does 5 mean? Well, that's basically the y coordinate, which in this case is the cost, and the x represents the hours. So I'll leave it up to you to interpret the rest of that. Number 13, what is the slope of the graph? Describe what the slope represents in this situation. Remember that the slope is 2. The slope is 2. Now let's write that in fraction form. So it's basically 2 over 1. And the 2 again represents the cost over 1, where the 1 represents the hours. So if we actually read this, this reads as cost per hour, and basically this is what the slope is right here. The slope is the cost per hour. So $2 for every hour, basically. So by looking at the slope, we can determine what, by looking at the slope, we can basically describe what it represents in this situation. Okay, so the homework for this is questions 18 to 22, and of course this is the video that you're watching. Now, when you're answering this question, it's very for number 18. Let's just take a look at that really quick. Let's look at the first paragraph. Use this information for items 18 to 22. makes some of the water features at Sapphire Island are periodically treated with a chemical that prevents algae growth. The directions for the chemical say that to add 16 fluid ounces per 10,000 gallons of water. Number 18. Make a table that shows how much of the chemical to add for water features that hold 10,000, 20,000, 30,000, 40k, 50k gallons of water. Now, when you're making your table for question number 18, pay careful attention to what your x and y are going to be. So remember, x is your independent and y is your dependent. So what are our two variables here? So one variable is going to be the fluid ounces. So is that going to be the independent or dependent? And the other variable is going to be the 10,000 gallons of water. So you have to think carefully here. Which one is the independent or dependent? Does the fluid ounces depend on how many 10,000 gallons of water you have, or does the 10,000 gallons of water you have depend on the fluid ounces? So I'll leave that up to you to decide, but you must get this correct, or else it's going to mess up your answers for 19, 20, 21, and 22. So if you have questions, ask me. Tell me what you think, what is the independent variable and which one is the dependent. So be careful about that one. Thank you for watching.